an electron with a mass of 9.11 times 10 to the negative 31st kilograms, which is moving with a speed of 1.10 times 10 to the 6th meters per second.
Another definition. Well, remember, one of the things we said was that the amount of work, right, is equal to the change in the kinetic energy. And also the change in potential energy. I mean, if I wanted to make this question really perfect, I'd say as it's moving horizontally. You know, then it'd be perfect. Then we know for a fact there's no change in potential. If on the other hand I said it's moving, say something like that, then there's a change in potential, so you have to include the change in potential in this. Right? Okay. So horizontal is change in kinetic. So this work is going to be 1/2 mv final squared minus 1/2 mv initial squared. So what is v final squared? V final. It's saying in the question, it's saying it's going to stop the electron.
So 0.
So 0, exactly. So they go to 0. So you see this is negative. So it's work taken. It takes work to stop it. That's why it's negative, right? It requires you to do work. So the amount of work required is literally just minus 1/2 mv0 squared, right? Which is 1/2 9.11 times 10 to the minus 31 times 1.1 10 to the 6th squared, right? So that's 12. Okay, so it's 9.11 divided by 2 times 1.1 squared, and that's 12, right? So it's 19. It's 19. Is that right?
I thought that was 19. Yeah. This is a negative 19. But it's a negative 5.51 times 10 to the negative 19.
Negative 5.51 times 10 to the minus 19.
Mm-hmm.
Yeah, it makes sense because this is going to be about 1, so it's 9/11 and a half, you know.
The choices are positive with that.
That's all right. It's just saying the amount of work. This just tells you if your work is given or taken.
Oh, okay.
Remember, it's like the speed. Speed's always a positive number, but it's positive in every direction. In case of work, it's either given or taken. What happened?
I went like this and jumped back and I was like, why?
Oh, you almost had a heart attack? Okay, I don't know if you can read that, but okay. So any questions in this one? You notice this is similar to the previous question, or a couple questions back. So I asked you that quite a bit in terms of this definition. Number 8.
A 66 kilogram skier starts from rest at the top of a 1,200 meter long trail, which drops a total 230 meters from top to bottom. At the bottom, the skier is moving 11 meters per second. How much energy was displaced by friction?
Okay, so if you think about this, it's a pretty straightforward problem, right? You got an H, okay? He starts here and ends up here. At this point, he's just got potential energy, which is his total energy. At this point, he's got just his kinetic energy, which is his total energy, okay? If energy was conserved, this should definitely equal that, right?
Mm-hmm.
But if it's not, if there was friction lost, right? If there's energy lost to friction, then it'd be this equals this plus that. Because the total energy's got to be conserved, right? So in this case, the total energy would be potential energy equals the kinetic energy plus the energy lost to friction. Okay? So that means you'd have mg8. mgh equals, in this case, it's going to be 1/2 mv final squared plus the energy lost to friction. So we bring it over on this side, right? We end up mgh minus 1/2 mv final squared equals the energy lost to friction. MGH is 66 times 9.8 times 230 minus 1/2, 66 times 11,121, which is 11 squared, right? Is that right? Like we're missing something. Okay. It's 33, 121. Yeah. Like 10 times. I don't have a calculator with me.
Negative 14,471.
Negative 14,000. Well, I mean, the amount of energy is lost, right? But it's 14. Is it 14,000? Should be bigger. Okay, 14,000.
Yeah, I can redo it.
960.
No, 14,471.
71 joules. Okay. Okay. No, it sounds about right.
It's positive.
Yeah, it's positive, yeah.
Oh, there's an extra 7. I'm sorry.
Oh,
After
there
that
is?
first 7, there's
Yeah,
another
that's what I
7,
thought,
and then,
yeah, okay. Yeah, I thought, so that's a typo in the answer then, right?
Yes.
Extra 7.
Extra 7.
Well, it's too bad it's not the test, right?